All right, two more graphs to look at in chapter 8.3. The first one I'm going to do is this one, which is 3x squared over x squared minus 1. So vertical asymptote, set the denominator equal to 0 and solve. And you can do it by the square root method. And when you square root both sides, you have to make sure you include the plus and minus 1. So your vertical asymptotes, this time you got 2, are at positive 1 and also at negative 1. Okay, so you got 2 this time. That's because it's a quadratic on the denominator. Now this one, the degrees, just like the last problem we did, the degrees are the same. Okay, it's got x squared over x squared. So you are looking at the ratio of the leading coefficients, which is 3 divided by 1, which is 3. So your horizontal asymptote is up here at 3. And again, you'll get kind of visual confirmation of that when you graph this. You can see that these two graphs look like they're getting kind of horizontal at about a height of 3. But we have 3 different segments of this graph. Let's focus on the N shape in the middle, which will be in between the two errors. And there's only one point that shows up there, which is 0, 0. But you can tell it's an N shape by looking at the graph. So just make your graph look similar to what's on your calculator. Okay. Now your other two are going to be in these two segments of your graph. So second graph, plot a couple points. Actually, I can only plot one. I'll give you a bunch of fractions, which I don't want to do. I want to plot negative 2, 4, which is right here. And I want to make my graph look like it did in my calculator. And then the same thing on the other side at positive 2, 4. Okay, so your domain is going to be all real, except x cannot be equal to positive and negative 1. Now, your range for this question is a little bit tougher. It's got 2 different parts. Okay, if you look at it, there's 2 pieces of the graph that are above this dotted line, and then there's a piece of the graph that's below that height of 0. So let's focus on the top part first. Okay, look at just that part of the graph. My y values can be greater than that horizontal asymptote at 3. So my range can be y greater than 3, or it can also be this piece down here, which is less than or equal to 0. All right, last one, still from section 8.3, is x squared minus 2x minus 3 over x minus 4. The vertical asymptote, set the denominator equal to 0 and solve, and you get 4. So x equals 4. But because this one is top heavy, this is just memorization, it's top heavy because you got an x squared on top and only an x to the first on the bottom. So your degree on top is bigger than your degree on the bottom. So because of that, you have no horizontal asymptote. If it's top heavy like this, you will never have a horizontal asymptote. So when you graph this in your calculator, this is what it looks like. And you can only actually see half of this graph. So if you were to zoom out, if you hit zoom 3 and then enter, you can see this graph actually has more to it. Okay, it's symmetric in a way on both sides. And to find that, you're just going to go to your table of values, find 4, which should have an error next to it, and then just plot the points around it. And since my graph does not fit, you may want to change the increments of these to 2. So like this should be 2. This should be 4. I'm going to make sure your graph paper will have no numbers on it for this type of question. But you're going to change those to increments of 2. So when you plot this point, 3, 0, that's right here. I'm going to plot, let's see if I can do some other ones, negative 1, 0. See if I can do another one. No, not really. But I'm going to make my graph look like this. Okay, so it's going to come up through here, come through this point, and then slope back down and go diagonal. Again, not be real picky about this. There's not very many points you can plot. I'm going to do the same thing on the other side. Okay, on the other side of the error are my positive ones, which I can do at 5, 12. So over 5 up to 4, 6, 8, 10, 12. I can do 9, 12. And again, it's going to look like our graph. It's going to come down, loop through those, and then back up at a diagonal. Now your domain for this is all real except x cannot be 4. Okay, I'm not going to ask you for the range on this. It would be too tough to do. All right, the last piece of the test for graphing are going to be end behaviors, talking about what graphs are doing as x approaches infinity or negative infinity. So the first one here that I want to focus on is the exponential one. And what we're doing is we're trying to figure out what is y doing as x approaches infinity. So as my x values get bigger and bigger as it moves further and further to the right, my y's, which are my height, are approaching one of 3 things. It's either approaching a number, it's approaching infinity, or negative infinity. And because we're moving to the right, we're going to be slowly approaching this horizontal asymptote, which in this problem is located at -2. Now, as x gets smaller and smaller, as my x moves to the left forever, as it goes to negative infinity, my y values are going to be getting larger and larger. It's going to keep going up, up, up forever. So it's going to positive infinity. We have a lot of these in our notes too, so make sure you look at those as well. The second one is a quadratic. Same thing. If you notice on both ends, there's no horizontal asymptote. So that right there gives away that it's going to be either infinity or negative infinity for these 2 answers. Now, because they're going up on both ends, as I move further and further to the right, my graph is going to continue to go up. It's going to go to positive infinity. And the same thing on the left. As I move further and further to the left, my graph is still going up forever. So both of these are going to positive infinity. This is a cubic graph, which you will need to know how to graph just by plotting points is all you have to do. But this one, as I move further and further to the right, if you notice, my graph is going to start going down forever, and it will continue to go down. So this is going to go to negative infinity. And as I move to the left forever, my graph is going to start going up without stopping, but going to positive infinity. All right, one more. This is a quartic graph, which you'll need to know how to graph as well by plotting points. This one, they're going down on both ends. Okay, so as I move to the right forever, my graph is going to go down forever to negative infinity. And as I go to the left forever, it's going to be doing the same thing.